Hi guys, today we're going to talk about solving inequalities, and the I can statements we're working on are I can solve word problems leading to inequalities in the form px plus q is greater than r, or greater than or equal, oops, it's supposed to be an equal sign there, equal to r, looks like that, or px plus r is less than r, or less than or equal to r, where p, q, and r are specific rational numbers. So x will be, in this case, a variable. And the other I can statement we're working on is I can graph the solution set of the inequality and interpret in the context of the problem. And today we're going to mostly focus on solving and graphing in this lesson. So if we think of an equation as a balance, we can think of an inequality as something that is not balanced. And it's all in the word. In, meaning not, equal, not equal. So, for example, 10 pounds plus 15 pounds is greater than 10 pounds. You can solve an equation by adding the same amount to both sides, or by subtracting the same amount from both sides, because it's keeping an even balance on the left and right side. You can also do it by multiplying by the same number on both sides, or dividing by the same number on both sides. And in all these cases, you will, if you're dividing, adding, subtracting, multiplying by the same number, you're going to keep that balance. When it comes to solving an inequality, you can use the same methods. Look, if I add 5 to both sides, 25 plus 5 is 30 pounds, and 10 plus 5 is 15 pounds, so you'll see the left side is still greater than the right side because it still has more pounds or more weight on it. You can also subtract the same amount from both sides. So 25 minus 3 is 22 pounds versus 10 minus 3 is 7 pounds, and 22 is still greater than 7. You can multiply both sides by the same number. 25 times 2, that would give me 50 pounds here on the left, and 10 times 2, that would give me 20 pounds on the right, so the left side's still greater than the right side. And by dividing. 25 divided by 5 is 5 versus 10 divided by 5, which is 2, and so the left side, is still greater than the right side. So all those methods we've been talking about with solving equations, those still apply when we're solving inequalities. There is one little difference, however. When we are solving an inequality, we need to learn how to graph the solution. And this is very simple to do. You solve an inequality the same exact way you would solve an equation. Okay? Since I have addition in my inequality, that means I'm going to need to subtract, and I do that from both sides. Again, I'm trying to isolate the variable, and I call it a variable in this situation because when we're solving inequalities, we're going to give a set of answers instead of just one solution. So anyways, when I subtract 5 from both sides, that leaves me with x is greater than 6. Notice the inequality symbol didn't change. That will change in the future, but for now, for the problems that we're doing right now, the inequality does not change. If it's greater than in the problem, it's going to be greater than in the solution. So now I know that x is greater than 6. This tells me that it cannot be 6 because 6 is not bigger than 6. But x can be anything bigger than 6. X can be 6.00000001 because that's greater than 6. But since it can't be 6, we draw a circle on the number line at 6. And we don't shade it in, it's just a circle. And then we ask ourselves, okay, well, if x has to be greater than 6, what number on the number line is greater than 6? Well, 5 is less than 6, but 7 is greater. So I'm going to highlight my number line, or darken my number line, going in the direction of all the values that are greater than 6. And that is the solution to this inequality. X can be any number bigger than 6. You can go ahead and plug some in. Let's try 7. If I wanted to do 7 plus 5, that should give me a value greater than 11. Well, 7 plus 5 is 12, and 12 is greater than 11. So this is a true statement. If I'm not sure which way to go, you can go ahead and you could have plugged in 5, which is less than x. 5 plus 5 needs to be greater than 11. Well, 5 plus 5 is 10. That is not greater than 11, so I know that 5, or any number less than 6, can't work. So they're not solutions. Now, when I have a problem like this, x minus 2 is less than or equal to 5. That's telling me that both sides of my inequality can be the same. It can be less than, or it can also be equal. In either case, I still solve it just like I would solve an equation. So I have subtraction, which tells you that you need to do addition. And what are we going to add? We're going to add 2 to both sides because, again, we want to isolate our variable, get it by itself. When I do that, my 2's cancel out, and I get x is less than or equal to 7. Since x can be 7, I'm going to still draw my circle at 7 on the number line, but I'm going to shade it in to show that my solution includes the number 7. Now I ask myself, what value of x can I plug in so that it is less than or equal to 7? Well, is 6 less than or equal to 7? Yes, it is. 8 is not less than or equal to 7. So I'm not going to shade in the direction of 8. I'm going to shade in the direction of 6. And I'm going to darken that number line to show that my solution to this inequality is 7, which is included because I've shaded it in, and anything that is smaller than that. Again, you could go in and check your work by plugging in any number. You could plug in a 5. 5 minus 2 has to be less than or equal to 5. Well, 5 minus 2 is 3, and 3 is less than or equal to 5. When I plug in 7, my solution to the problem, I can plug in 7 minus 2 is less than or equal to 5. Well, what's 7 minus 2? That's 5. Is that less than 5? No. Is it equal to 5? Yes. Because in my solution, it can be less than, or it can be equal to what I get when I solve my inequality. The same rules apply when I have multiplication in my inequality. I'm going to solve it with division. So in this case, I'm going to take 3x is greater than 12 and divide it both sides by 3, which cancels out these 3's, so I get x is greater than 4. When I go to graph it, I start at the 4 and make a circle. Now I ask myself, should I shade that in? Well, can my solution be 4? It cannot, because my inequality says it has to be greater than 4. So it can be any little fraction greater than 4, but it cannot be 4. Since x has to be greater than 4, I ask myself, is 3 greater than 4? No, it's not. So I'm not going to shade in the direction of 3. Is 5 greater than 4? Yes, it is. So that tells me to shade or darken my number line in the direction of 5 and any amount greater than 5. In this problem, I have division, so that tells me I need to do multiplication. And since I'm dividing by 4, I'm going to multiply both sides by 4. And these 4's cancel out, which gives me x is greater than 2 times 4 is 8. Can x equal 8? No, it cannot, because my inequality symbol says it can only be greater than 8. So that tells me I'm going to put my circle at 8. I'm not going to shade it in because it cannot be 8. And then I ask myself, is 7 greater than 8? No. But 9 is greater than 8. So I'm going to shade my number line or darken my number line in the direction of 9 because 9 is greater than 8. But I didn't color in my circle because it cannot be equal to 8. In this problem, I have addition, so I need to do subtraction. And to isolate that x, I'm going to subtract 7 from both sides, which leaves me with x on this side is greater than or equal to 6. So when I go to graph it, I'm going to put a circle at the 6 and ask myself, can x be 6? Yes, it can, because it's greater than or equal. So that tells me that I need to shade in this circle. Now x has to be greater than or equal to 6. So is 5 greater than 6? No, it is not. Is 7 greater than 6? Yes, it is. So I'm going to shade in the direction of 7. Let's look at one last example. In this problem, I have addition, so I need to do subtraction. I'm going to subtract 4 from both sides, and that leaves me with x is greater than or equal to 2. Now I need to graph this. I put a circle at the 2 and ask myself, can x be 2? And the answer is yes, because it's greater than or equal. So it can equal 2. Since it can equal 2, I'm going to shade in my circle and ask myself, is 1 greater than or equal to 2? No, it's not. Is 3 greater than or equal to 2? So does 3 make this statement true? And the answer is yes, it does. So I'm going to darken my number line in the direction of 3 and getting larger. So it's going to go to the right. Now it's your turn. On the next 2 slides, you will have 2 problems to solve. You need to solve the inequality, then graph it on the number line. Pause the video and do 1 and 2. When you're done, hit play. Here's number 3 and 4. We are done with the lesson now. You can go back and watch any portion of this video as many times as you need to, but don't forget to WSQ in your notes.